Hello DE students! Today we are talking about digital component identification. So we've talked about analog components already, resistors, capacitors. We are now moving into the digital side of our component identification. So make sure you have your engineering notebook ready and let's get started.
This lesson will focus on an introduction to logic gates and integrated circuits. In this activity, you will investigate both combinational and sequential logic gates. You will be asked to simulate simple circuits using basic logic gates. You will then complete a truth table for each logic gate based on the outputs generated from your simulation. The names of many of the fundamental logic gates in digital electronics are based on the logic output from the gate. So how do we get to digital components? The transition from analog to digital components began with transistors, which are electronic devices that are used to control the flow of electricity in electronic equipment with at least 3 electrodes. A small voltage controls a larger voltage, so it can act as an amplifier or as a switch. A transistor is completely off or completely on. From transistors, we move to gates. Transistors and resistors can be arranged to create desired outputs based on specific inputs, which are logic gates. Because transistors only have 2 states, either on and off, the binary number system and Boolean algebra are used to describe the relationship of the inputs to the outputs on these gates. We're going to be looking at both the binary number system and Boolean algebra a little bit later in this course. These input-to-output relationships can be shown on what we would refer to as truth tables. The most recent transition that we have in electronic components are the creation of integrated circuits, or ICs. An integrated circuit is a component that is multiple components built into a single package. Most of the time, this is a creation of a logic gate. So how do we know what each component does? That is based on the truth table. So a truth table is a list of all possible input values to a digital circuit. So they're listed in ascending binary order, and the output response for each input combination. Your inputs are labeled as X and Y, and these could be buttons or switches. In most of our simulations, we'll be using switches. The output Z might be a buzzer or an LED. For us, we'll be using LEDs. For 2 inputs, there can only be 4 possible arrangements of the inputs, or the switches. An example of a truth table can be seen on the right. You'll notice that the column is listed as 0, 0, 1, 1, while the second column is 0, 1, 0, 1. These are binary sequences, and when combined, they create various outputs. So in order to understand the structure of a truth table, it's helpful to understand how to count in binary, which is a base 2 number system. We're going to take a much closer look at binary very soon, but for this activity, you'll need a basic understanding. The ascending rows of this truth table represent a count of 0 to 3 in the binary number system if you look at the inputs X and Y together. Like I said, for this activity, it's only important to know that the truth table is showing each of the possible output responses for each input combination. All possible input values to a digital circuit are listed in ascending binary order in the truth table. Again, we're going to look closer at binary in later activities. For this activity, all you have to understand is if we have input X and input Y, what are we getting for Z?
Alright DE students, that is a wrap on our digital component identification lesson. If you have questions, make sure you've jotted them in your notebook and that you have them ready for class, because we are going to dive right into this when I see you next time. So see you real soon. Bye!